Hello. So a while ago, I started to learn from the REST crash course on how to create a linked list. So I'm going to attempt to type it in from memory, but it's not that I've actually just memorized it like a robot. I kind of pretty much understand it. So as my memory fades, hopefully I will still know how to create the code, even if I've forgotten some of the finer details. So if we go to source, MV main, and I'll just make that a bit bigger. Right, let's start. So struct node, and it's going to take a generic type T, and we will put in data, which is of type T, and we want to have next. And I used to think of this as previous, but apparently it is just next. Next is kind of the how it's always been. And then we want to use a box because it's going to be on the heap because we get into problems with kind of like recursion otherwise. And then it will be a node, which is type T. You see the recursive part of it, node T is inside node T. But because it's inside a box, it's a smart pointer. So it's just kind of like the reference to it. Right, so that's the node, and then the linked list actually contains the nodes. So we will make a linked list, which again uses a type T. So we put that there, and it's just head. So the linked list needs to know its head, which is can be some or can be none, because when you first create it, it will just be nothing, or it won't have any nodes. So it needs to, sorry, capital N for node. T, I think it's the right number, closing brackets. Yeah, it's happy. So far, so good. So then we want to use a import. Then when you're using an import, it's using generics. Then you have to put the T in front of links list as well. Then the T there. Um, okay, let's put in a function. So we're going to have a function new, which will return self. We'll have a function update, which it will mutate, but it won't actually return anything. And then we'll have a function. Actually, let's call that. We'll leave it as update. It could be push. We'll call this. This will be pop. Let's call it push. That's going to take immutable mut self because we're going to modify it and say it's not going to return anything. But we need to pass in the data as well. So t pop is just going to be some mut self, and we return what it's actually doing. So we could put option t there as well. Why is it unhappy? Because we haven't done anything for it yet. So we're going to return a linked list where the head is none, capital. Okay, so that one's happy. That won't be happy until we've given it something to return. Let's do push. So we want to push a new node onto it. So we'll do box new node. Then we'll put some stuff inside the node. And then if we just say let node equal box new, we'll fill that in a second. And then we actually want to, no, we don't return anything. We'll just say self.head equals some node. because we have to use sum because it's the linked list struct up at the top is expecting an option of a box of a node. There we go. So node is actually a box of a node of a type T, and then the sum, we just prefix it with sum. So let's actually put something in here, and we'll say data is just data that we pass in, so we can do data with a comma, and then next effectively will be the previous, which will be self.head.take. And because it's inside the curly brackets, we don't put the semicolon on the end. So we've got a new that creates the new linked list. We've got push that pushes some data of type T onto the linked list as the next node. So each node will contain some data. It could be numeric or it could be text. Right, so then we need to say, we need to capture when we pop, we need to capture the current, the current head, equals self.head.take. And take actually does take it. It kind of captures it or consumes it even. So, and then we need to match on whatever the current head is, because then we want to get the node out of it. So then it's we'll be getting some node, and with that node, we then want to do some stuff to it, which we'll just do down here. Or if it's none, then we'll just return none. Okay, and then we just need to fill this in again. So we'll say, again, we need to update the head. So self.head equals node.next.take. Because basically we're modifying the node we're modifying the node which is at the head, and then we'd want to return we want to return the node data because that's what the option of the T will be. And that's not happy. Why? I know, because the node needs to be mutable, and that's happy. So we've got the new, we've got push, we've got pop, and then we need length. So this is actually the one that took me the longest to learn, which just takes reference to self, and it will return just a U8 because we're returning the length of the linked list. Let's get rid of that hello world, doesn't need that. So then the length, we need to set up a mutable, so let len equal 0, and then we need like a moving, like a pointer that moves. Let mut current equal self. What is it? We need to. Needs to be a reference as well. So self dot. And then we need to get the next, I think it is. Then we'll say while let some nodes equal current. Nah, case as well. And at the end, we want to return the length. So in here, we just need to do length plus equals 1. And then the current, we need to just set the, which end is it? We need to set the current to the node. Current equals node dot next. Yeah, I think that should be, that's head, isn't it? And that needs to be borrowed. So we'll get the current head, and then we will keep iterating over the next node until such a point where we no longer get a next because it doesn't exist, and that means we will have reached ground zero, so to speak. So, right, let mut, we'll create a linked list equal linked list new. So the screen's getting a bit, let me get that up into the middle. So that's going to create a linked list, and that's not compiling because it needs some more type information. Consider giving linked list an explicit type is struggling, isn't it? Let's do linked list dot push. Because we made it generic, we could put a on, and that will work. That's got rid of the error. Replace that with b. And we kind of know what we know what the length should be, but let's just check it anyway. So dbg linked list dot length. So we should just see the number 3, I think. Yeah, it's a bit obfuscated there. Let me just do that. And what's gone on there? It's not happy, is it? That's better. Right, okay. Let's just do cargo run dash q. Here we go. Links. I'm just debugging this. So links list length equals 3. And then if we just let's pop. So links list dot pop. We don't need to pass an argument. And then let's just do that again. So we should see 3, and then we should see 2. There we go. 3, then we've got 2. So that's from, without any notes or anything, I've managed to successfully kind of remember the code, but I probably practice this every so often, but even though when I don't remember every single kind of little nuance or every little bit, I've kind of made sure that I understand the kind of the overall concepts enough such that I know what it's doing, and once I know what it needs to do, then I can kind of, with a little bit of trial and error, I can just about remember what I need to put in the code to make it work. Like up here, I put in self.next, which was wrong because the current is actually, I need to get the head. And then node.next here just kind of it does the iteration for you. So it takes you to the value of the key, which is next. So next is the key there. So that's not the same as next there. It's not the iterator next. It's next as in that key. So it keeps on each node, as it keeps going through the nodes, it just keeps following the next. So it follows next until it gets to the next node. And then when it gets to the next node, it gets next from the next node. So it's kind of recursive. And the whole reason it all works is because we're using box, because box is using a reference, which is a known size. and we're not getting stuck into some kind of sort of Stack Overflow error that we would get if we didn't use box, which is one of the issues with implementing a linked list in Rust. But this kind of just shows that you can do a linked list in Rust. Um, I don't know any more than that really about the technicalities or the performance issues and so on and so on. But yeah, and also there is a linked list crate for Rust, I believe. So, but this I believe is a very good learning exercise, and it really does kind of expose you to parsing options, working with generics, um, yeah, uh, mutating. So that's quite good. That's quite interesting because what you're doing there is you're taking a node and then you're kind of almost you're effectively mutating it in place. Um, and that's self. I've seen this written differently where there is. Let me turn off the inline hints. I've seen it written where there's ref there and then there's the asterisk there. So they still balance because you've got the deref there and you've got the ref there. They're kind of negating each other. And you use ref, so lowercase ref, you use that with pattern matching. So if you come across something that's got that asterisk there, then you would need to use ref here. But it works without. And again, the kind of the intricacies of that are kind of beyond what I can remember. I have looked it up, and I understand that if you use pattern matching with something and it's dereferencing, then you can use ref. It's all about having the ref on the left-hand side and the deref on the right. But yeah, so it's used if you see ref, it's because you're doing pattern matching. Otherwise, you could just use because pattern matching is matching on a reference, not on the ampersand, something like that. So yeah, there we go. I hope this has been I don't know, educational, informative, inspiring. I've been learning Rust for just over a year now, and this example I've kind of practiced so many times, and it's almost like learning to play music. You just kind of there's certain tunes that you think, well, I need to be able to play that tune off by heart. So, or I think it's called rote learning, isn't it? And again, I've learned it. I haven't memorized it virtually, but I've also once you've almost memorized it, you start to then also understand what it's doing. So that's kind of one of the key things here. Don't just memorize, actually understand what each line does. And you won't memorize and understand what each line does, but if you kind of memorize a chunk of it and then you're as you get to memorize it, you will then just start to get an instinctive feel for what it's doing. For instance, here head.take, so you're taking the current head of the linked list, which is effectively the most recently added node. So you take the most recently added node and then you're mutating it to get the next. So next to me is actually more like previous. And what we're doing here is we're popping, so we're downgrading the list. We're going from, say we had 3 things on it, we're then going to take the 3rd thing, and then that just leaves us with 2 things because it's last in, first out, effectively, isn't it? My other thing I'd kind of do now is if I'm doing sum, I just put I make sure I put the comma and then the none at the end, and then I come back and fill that bit in. It just saves getting in a muddle and getting loads of. Because then once you've typed these 2 lines, it should all you get rid of any error warnings. And when you're doing stuff with the nodes, just try and remember whether you need to borrow or whether you need to mutate something. So in pop, we're actually mutating the linked list, but with length, it's kind of a read activity. We're not changing the list as such. So yeah, there we go. And I've put in ABC, but because we've made it generic, we could equally do 1, 2, 3, or whatever you want, and they don't have to be consecutive. So we could do that should still display 2 and 3 because it will have 3 things on the stack, and then we have 2. So there you go. That's the linked list in Rust. Thanks for watching. Be back soon.